Welcome to this brief video lecture as part of the course Qualitative Methods for Business and Management. This brief video lecture is about qualitative research genres. That means we have two parts that we want to cover here in this online lecture. First, trying to identify the right qualitative research genre based on the type of research question we are trying to pursue. And second, understanding different research design choices as they relate to the reasoning strategies induction, deduction, and abduction. So we will cover these two parts in this brief lecture. First, we realize there are different qualitative research genres that we have explained earlier. You could think of them as different approaches that you can position on a Cartesian map with two axes, from deductive strategies to inductive strategies. That's the y-axis in this figure, and from interpretation-centric to data-centric, that's the x-axis in this figure. And the data-centric versus interpretation-centric we covered in class. This is based on primarily on the worldview and the philosophical assumptions that the researcher brings about. On the right-hand side, we have the data-centric view, which aligns with a positivist view of the world. And on the left-hand side, we have approaches that are interpretation-centric, so they align more with an interpretive view of the world. Which type of genre really is the most appropriate is a question of the research phenomenon that you are trying to study and the research question you are trying to answer. So the genre is a choice that we make during the phase of research design, and it follows logically the question that you're trying to answer. Any one study, we're trying to answer one particular question. This question is important because it frames what the phenomenon or problem is that we want to study. When we find an answer, we turn back to the question to determine whether we have sufficiently and comprehensively answered this question. And our research design and the choice of genre that we pick as part of our design really is the strategy that we are pursuing to answer this particular question. Moreover, research questions are important for any readers of your work. That might be yourself, could be your advisors, your research team. It could be other stakeholders, examiners, for example, of a thesis you might write, reviewers, or simple other readers that are interested in your research. The research question provides a frame that brackets the investigation and its representation in the final research report. So basically, any study is about the question and how it's being answered. Now, in very simple terms, we can distinguish two types of research questions. Yeah. On the one hand, we have the so-called type 1 questions, which tend to be what questions, who questions, or where questions, or when questions, but they feature, not that prominently. So what, who, and where questions, and these questions tend to focus on issues we want to describe or explore, typically because very little knowledge exists about them. What's happening? Who's been doing this? Where is this a case or where is this a problem are questions where we don't know the answer and we need to explore the answers and describe what is happening. Contrasting to this are so-called type 2 questions, which are how and why questions. These are usually not as descriptive or exploratory, they are explanatory. How and why questions ask for answers about the mechanisms that are at work, sort of like the gears that are in motion that explain a particular phenomenon and how or why it came about. So, type 1 questions, what, how, where, when, seek to learn what the situation of a phenomenon looks like. We ask these questions about phenomena that are new to the world, that are unknown to the world, that are newly emerging, or very simply that we've never bothered to pay much attention to. To bring one example from recent years, at the onset of the COVID-19 pandemic in early 2020, the world realized there was a new virus. It looked very dangerous. People were dying, and we didn't know much about it. We knew it was different somehow from other viruses we've seen in the past, like SARS, influenza, and other types of viruses, but we didn't know much about it. We didn't know what it was, how it worked, where it occurred, what might be done to combat it, and so forth. So the first step was to find out everything about it, what it looks like, what it does, what its structure is, where it occurs, who can be infected by it, and so forth. So in the beginning, we asked type 1 questions: what, where, when, and to some extent also how. How are people being affected? What makes it spread? What makes it so dangerous? And so forth. Then type 2 questions, they seek to explain the cause and effect mechanisms behind why and how something works. Why is the virus so dangerous? How are the transmission and infection mechanisms really working? Yeah. So during the pandemic, we wanted to find out not only what the virus is, but how it infects people. So this question was important so we could devise treatments and vaccinations that hinder this mechanism by which the virus infects people. Yeah, so we wanted to understand how it infects people and how people can be infected by others through transmission mechanisms. This is important because we were looking for interventions that would stop that. These are type 2 questions, explanatory questions, whereas the first questions were simply descriptive and exploratory. We didn't know, we wanted to discover as much as possible, and we wanted to describe it as rigorously and systematically as possible. What this example also shows is that very often type 2 questions temporarily succeeds. That means follow type 1 questions. It's very difficult to explain a phenomenon without first systematically exploring and describing it. So normally in a situation where we have something new to the world, we start with what and how, with what, when, where questions, type 1 questions to describe it as good as possible. And then we move to type 2 questions that explore how exactly something works. An example here would be the discovery of the DNA double helix, so the structure of the human genome. The initial breakthrough was just the work that allowed us to find a structure that describes the human genome as this double helix kind of model. That was very important. Now that we knew what it looked like, we can now start figuring out how to explain how it works, why it works, how we could intervene through genetic manipulation, genetic treatments, whatever else we wanted to do. So if we have the research questions typically of the sort of a type 1 or a type 2 question, then we need to figure out how do we design our study, our qualitative research study, to answer this particular question. And here I want to talk specifically about induction, deduction, and abduction. So once our research question is well specified, our next challenge is to craft a plan of action to answer the questions and test our theory, our proposed explanation about its answer. This is what's called a research design. So a research design is a blueprint, a plan of action for the collection, measurement, and analysis of data. Really, the model of the procedures we're going to step through to find an answer to the question that we're asking. Now, what's important is that research design involves a lot of choices, and it depends on how we want to go about reasoning about our answer. Yeah, reasoning is a logical skill, a cognitive skill where we try to figure out how do we find an answer to our problem. Typically, we use a variety of different reasoning skills, and the most prominent of these are what are called induction, deduction, and abduction. I will explain them in a second. And this is important because these reasoning skills feature in different research strategies. Yeah, typically we have strategies for exploration, we have strategies for validation, we have strategies for rationalization, and they link to these different reasoning skills. So let's explain them. Induction is a form of logical reasoning that involves inferring a general conclusion from a set of specific facts of observation. In induction, what we're doing is we are moving logically from the specific to the general. What we're doing this is we're trying to figure out hypotheses, propositions that we can formulate to declare general conclusion or theories based from observed data or facts or simple cases that we've seen in particular. Yeah. So here's an example. Every life form we know depends on liquid water to exist. Yeah. So when we look around, everything that's living beings, they all need water to exist. Therefore, our hypothesis is that all life forms, including those that we don't know of and those that we have not yet seen, depend on liquid water to exist. This is a form of induction. We are generalizing from what we can observe, living beings that we see, every life form that we know of, every life form on the planet Earth, and we're extrapolating from that a theory would be that all life forms need it. Where that is actually of prominence are some of the Mars discovery missions. The NASA, the Mars robot, whatever it was called, the rover, because this robot on Mars is looking for water. It's not looking for animals or aliens or anything like that. It's looking for water because water increases the likelihood there are life forms on Mars. Why is that? Because we think that every life form depends on liquid water exists, because this is what we see here on planet Earth. So induction is a very common strategy, especially in qualitative research, because in qualitative research, we typically study particular cases. One person, one organization, one particular project, one particular community or group or project, anything like this. So we study something in particular, look at observed data about this particular phenomena, and usually we then try to make conclusions about these kinds of phenomena, or kinds of problems, kinds of organizations in more general. So, what are the problems here? Problems is that we can never prove or justify our conclusions, our hypothesis. Yeah. So we can never prove that the explanation that we're offering, based on these observations that we have made now, that they really will be true. Yeah. So inductive arguments cannot be proven or justified. They can only be supported or not supported by the particular facts that we've studied to generate them. A second problem is that induction can be weak or strong. Yeah. So the inductive leap, so to speak, that I make can be more or less, faithful or plausible. So, for example, the induction, I always hang pictures on nails. This is what I do. Therefore, all pictures everywhere always hang from nails would be an example of a weak induction, because on my observation, all the pictures in my house is too limited to lead to such a broad generalization. Yeah. And it's very difficult sometimes to figure out whether or not our inductive argument is weak or strong, because we don't know how limited or generalizable our observations really are. So, what's the verdict about induction? Induction is an accepted and often useful pathway for constructing explanations and hypotheses. Yeah, because basically we offer some conclusions based on educated predictions. I studied a phenomenon in a number of cases. And within this limited number of cases, I've always found this particular mechanism, relation of phenomena to be at work. So all the evidence that I've seen so far lead me to formulate the proposition that it's always going to be that way. This is a much better prediction than having no observation. But of course, we can't conclusively prove it, right? So inductive theories that we generate, we don't know whether they work. We've only seen them work in a few cases. A second form of logical reasoning strategy is called deduction. Deduction is basically the opposite to induction. Yeah, deduction is a form of logical reasoning that involves deriving arguments as logical consequences from more general premises about something in particular. Yeah, we deduce a conclusion from a premise or an assumption or a theory to a specific instance, an observation, a case that we have in front of us. So this is a very common approach in science. Yeah, it's basically the main model, the so-called hypothetical deductive model. We start with a hypothesis, an assumption, an expectation that we have. We take that as a premise, and then we derive from this premise some conclusions about observations that, if our premise is correct, we should be able to see this and this and this in the real world. And these we can then test. For example, an experiment. An experiment is a hypothetical deductive. I need to have a hypothesis, a premise, such as this drug will cure cancer or this drug will cure your headache. And then I design an experiment to test this particular premise. Yeah. So here would be an example. All men are mortal. Socrates is a man. Therefore, Socrates must also be mortal. From the general premise that all human beings are mortal, and I now look at a specific human being, Socrates, I can deduce that whatever applies to men in general will also apply to Socrates as a specific fact. And I can observe him over his lifetime, and if at some stage he dies, I can say, see, I was right. What are problems with deduction? A key problem of deduction is the problem of soundness versus validity. We can do deduction logically sound. We can follow the process of logical reasoning in deduction correctly, soundly, But if our premise is incorrect, our deduction, even though it's been soundly deduced, might be invalid. If we have the premise only quarterbacks eat steak, and we notice that John eats a steak, and we conclude John must be a quarterback, then this is a logically sound deduction, but because the premise was incorrect, the conclusion is incorrect as well. So induction and deduction both are very important to many scientific processes, from setting up a plan to collect data, to the challenges of developing new theory, to moving to research modes that allow us to validate, test, falsify, and evaluate a theory. We use induction to generate theory, we use deduction to test theory. What is very important is to realize that neither induction nor deduction alone are sufficient or complete. A third form of logical reasoning that works very differently is what's called abduction. Abduction is the process of making sense of an observation by drawing inferences about the best possible, the most plausible explanation. It's not a process of logical inference of deduction, so it's not quite the same process of induction or deduction. But instead, you can conceive of it as a trial and error search for a satisfactory explanation for an observed consequence after the fact, after we've observed it. Yeah. So you could call it informed guessing if you wanted to. What you're doing is you're observing a phenomenon and then you try to jump to the most logical or most plausible explanation, because in most cases, what is the most obvious explanation is usually also the correct one. Yeah. A phenomenon called the Occam's razor. Yeah. What's important here, this is not a strictly logical process, it's rather a creative process. We are conjuring hypotheses as an explanation for an observed consequence after the fact, and we're trying to be most possible, more plausible in our conjuring. Yeah, but this is creation, not a logical form of inference. So, what do we do? What do we use this for? Abduction is a process that we engage in when we try to discover entirely new ideas, new theories, rather than a mode of justification through deduction or formal inferences to induction. So we're not really generalizing from the data, nor are we using data to contrast or evaluate our theory. Abduction is a creative process that we use to generate entirely new theories based on observations, assumptions, or anything else that we may use as input for our informed guessing for what it might be a plausible explanation for something we want to explain. So here's an example that contrasts these things. So the example is always from the same setting, beans in a bag. And you can see here what the forms of reasoning are. In induction, we would make an observation. There are beans, they're from this bag. We do reasoning. We see that these beans are white. And we offer a conclusion that all the beans from this bag must be white because the ones that we see from this bag are white. So inductively, we could conclude that all beans must be white, including those that we haven't seen yet. Deduction work differently. We start with a premise. We start with a hypothesis. The beans in this bag will be white. We observe that a bunch of beans that we see, they're taken from this bag, and we conclude that these beans therefore must be white. Abduction would be, there's a rule, all the beans from this bag are white. We make an observation, these beans are white and near the bag. What is the most logical explanation or most plausible explanation? Well, probably the beans are from this bag. That's the most logical, satisfactory explanation for the observation. Why does this distinction matter? It's very important because qualitative research genre, different ways of doing qualitative research, can be used as tools to support inductive, deductive, and or abductive reasoning. We can use qualitative methods, different genres, for exploration, which often involves induction, for what's called rationalization, which often involves abduction, and even for validation, which often involves deduction. Yeah. So you see here there are interdependencies between different research strategies that manifest in different genres, and they have been designed quite conscientiously to support inductive, deductive, and or abductive reasoning because we know we need them. Yeah. What is also very often the case is that when we think of good research, whatever that might mean, we see that very often they involve several, if not all of these strategies. So we don't have to do only exploration, only induction, only validation. Very often we see studies that combine rationalization and exploration and validation, or even all three of them. Yeah. So what do we mean here? We mean with exploration the systematic discovery of things or phenomena that are new, that we encounter in common experience that we haven't discovered, or that are new to the world, or that we just haven't studied yet. Rationalization is a process of sense making. We have a puzzle or problem that interests us, and we are offering a rationalization, offering an explanation of how and why it works. Validation is the process of taking a hypothesis, a theory, a proposed explanation, and subjecting it to rigorous examination and testing. And you can see here how that typically involves hypothetical deductive work. We need that theory first to deduce from there particular observations that then must be true in reality if our theory is correct. That's a form of deduction. And then we can use our observations to either validate or invalidate the explanation that we're offering. So, and what you then have is the different genres that we started off. Remember, we had a distinction of different approaches based on deduction, induction, and data-centric, interpretative-centric. And they can now be placed to what extent do they support rationalization, induction, deduction, and so forth. Yeah. And this matters because really, depending on what genre you're in, you really have to follow different procedures, and you have to follow different rigor criteria. So criteria that allow us to say this has been good research. Yeah. So for example, we can use the genre of a case study both in inductive and in deductive ways. We can use a case study as a sort of experiment, if you want, to see whether a theory holds true. If we have a theory about how organizations work, then I can take a case of an organization where it should work and see whether it does work. That's a deductive strategy. And then we have particular criteria that we must meet: validity, reliability, and so forth. But we can also use a case study as a method to build new theory inductively. We can study the cases of a few organizations that do things, and then we could try to generalize from these observations to what other organizations might be doing. Yeah. I'm just going to give an example later on. We can also use case studies not to build theory, to rationalize, or to test theory, to validate, but also to explore, to systematically explore and describe. Here, then, in exploratory case studies, we have different types of criteria, yeah, that would allow us to assess whether or not this exploratory case study is a good one. Yeah, here we would not look for validity and reliability, for example. We would look for rich descriptions, authenticity, auditability, and reconciliation of multiple polyphonic narratives. So this is why these distinctions matter. Thank you for listening.